Everyone will get started here. A minute, wait another minute, make sure people find the right place here, get in and get their videos on. We have 22 students in the class. There's 16 students in here right now. So just hang tight. You read through that problem, think about it. Okay, everyone, welcome. Welcome to Calculus 1. So hopefully you all have seen my orientation video already. If you have not, make sure you get into Canvas. Let me see here. I don't want to go through all this, but hopefully everybody knows how to get into Canvas, right? To access this page. I have an orientation video here. Make sure you watch that, and it goes through a lot of the details about the class. Were there any questions? Anything I can clarify? Access, how about access to the ebook? If you are going in there and it's asking you to pay for something, do not pay for anything. They're working it out right now. They're fixing it. So hopefully by the next time we meet, everyone will have full access and won't have that trial period thing going on. Is anyone having any issues with that? Are you all getting trial period?
Yeah.
No?
I am, but I'll just wait and see.
Yeah.
I'll try it again later tonight.
Yeah, they're working on it on the back end. So I'm very confident it'll be taken care of. Just do not pay for anything.
Okay, yeah, because I'm having trouble with it too.
Okay, but you've got to make sure that you actually can get to it. That you should be able to get to the ebook. It's maybe asking you to pay or give you a trial period. So if for some reason you cannot get to the ebook, let me know, and that way I can send out at least the pages from the homework. Okay, well, I mean, if there's really nothing else, I mean, as far as technical questions about the class, everyone should have the schedule, should know kind of how we're going to do this. We're ready then? Homework assignments coming up. So this is new. I normally don't ask my students to turn in their homework, but I'm going to try this, see how it goes. Just keep in mind that the handwritten homework that you're going to submit as a PDF file, it's really, I mean, I'm not going to be checking to make sure you've done every single problem just like meticulously with a fine-tooth comb. It's really just to keep you honest about staying on top of your homework, all right? Making sure that you're keeping up with it, because the exams are going to be very similar to homework problems. And if you're not practicing, then, you know, what I'm trying to do here is save those 6 students who always fail because they just never have the discipline to do the homework. So I'm trying to kind of forcing them to show me they're doing the work. And it's an opportunity for me to take a look at your notation, how you're writing things, whether or not you're using correct notation. So your first assignment's due, what is that? Monday night? And you'll have to submit that as a PDF file. Let's see, let's take a look at the class and see how y'all have done with that request. Oh, wow, good. So I've got a lot in here. This is good. So let me just pick someone. I hope Devin, you don't mind, do you? Is it Devin or Devon? I don't want to say that wrong.
No, that's fine.
Okay. So let's see if this is right. Single PDF, 3 pages, perfect. That's what I'm looking for. Okay, that's what I'm looking for. I'll check everybody's to make sure. I'm not gonna do it right now, but I'll be checking to make sure everyone does that properly. That's the way I want you to submit your homework and your tests when it comes time for tests, and quizzes if I give you a quiz. All right, so I'm ready to go. I'm ready to get into this. I'm excited about this. I'll tell you more about myself throughout the semester. I'll kind of unveil more and more about me. I've been teaching for 20 years at Northwest Vista. I teach the calculus sequence, usually Cal 1, 2, and 3. I love the subject. I never get tired of it because it's an opportunity for me to watch my students be like, whoa, like, wow, didn't know that we could do this with math. So, you know, I'm ready to go. I'm geared up. So I have this first little thing for you to think about here. You know, looking at this line segment, just the numbers between 0 and 1, including the endpoints. We would call that a closed interval. And you might even, you know, recognize the notation like 0 to 1, or, you know, you could say X is an element of this closed interval. That's one way you could think about all the numbers between here. You could also do like set builder notation. All X's such that 0 is less than or equal to X is less than or equal to 1. I'm just showing you different ways of notating all the numbers between here and here. But what I'm asking first is how many numbers are in there? So someone want to tell me how many numbers there are?
Infinite amount.
Infinite number of numbers in there. That's correct, right? There's an infinite number of them. You'll never run out. You can never pick them all, right? You're always going to have more and more and more and more. One easy way to think about that is if I were to take the number 1/2, right? There it's in there, right? 1/2's in there. If I take half of that, I get 1/4. And if I take half of that, I get 1/8. Oops, 1/8. And I could keep doing that forever, couldn't I? Like 1/16, 1/32, 1/64. And I would never run out of numbers, and I would never actually reach 0, would I? It would always be some number a little bit bigger than 0. So there's an infinite number of numbers in there. Do we all agree on that? Okay. So the next question is, I'm just going to put infinity here for the answer because there's an infinite number of them. Next one is every number in here a fraction? What do you think? So imagine closing your eyes, reaching in here, and picking a number off this number line. Okay, boom, you just pick it up and you look at it. Is it a fraction? Guaranteed, is there a way to represent that number as a fraction for any number in there? What do you think?
Yes.
Yes, okay. Anyone think that there's not? Not every number is a fraction? Well, if it's not a fraction, what type of number would it be? Are there any numbers that aren't fractions? Do y'all know of any numbers that aren't fractions?
Whole numbers?
Well, a whole number would still be a fraction because if you take the number, it's not in this interval, but if you take number 4, you can look at that as 4/1, right? It's still a fraction. You could also look at it as 8/2. There's an infinite number of ways to represent it, but you could still consider it a fraction. Now, in math, we actually use a different word for fraction. We call these rational numbers. Rational numbers. Rational coming from the word ratio meaning fraction, right? So I'm asking you, is every number in that interval a fraction or a rational number? And I have at least one student said, yeah, that seems reasonable, right? Any other comments on that?
I would think all of them can be except for 0.
Okay, 0. What about 0? Okay, how about if I write 0 like this, 0/1? Is that still a fraction?
Rational.
Yeah, it's still rational, right? It's still a rational number. By the way, let me time out real quick here. What we're doing here is related to calculus. I'm trying to start this class off by just getting us to think about something that's going to be like intrinsically like embedded into this class. This idea of this number sense, an idea of what the number line really is. It's really going to help us as we move forward. Okay, so no, 0 is still a fraction. 1 is a fraction. Any number in there. So it's looking like every number is a fraction, right? It's looking like every number is a fraction. Well, it turns out that that's not the way the number line works. There are actually numbers in here that are not fractions, and they're called irrational numbers. And you've probably heard of irrational numbers in your life. You've heard of, can anyone tell me of an irrational number that they may have heard of before?
Square root of 2.
Yeah, the square root of 2. Okay, that's an example, the square root of 2. Anyone think of another one? Or heard of another one?
Pi.
Pi, good. Any others? There's usually one more that students have heard of. College algebra.
1/3.
Okay, so 1/3 would be rational. That would be a fraction, 1/3, right? But that's where I think you're starting to get on to like the idea here. 1/3 seems different than these fractions, and it is, but it's still categorized as rational. How about E? Remember, E is that base for the logarithm and also the natural exponential function, e to the x, right? That E, but E was a number, right? 2.718, something like that. Yes? So what makes an irrational number irrational, and what makes a rational number rational? It's a very simple idea. Well, not simple idea, but it's easy to distinguish the two. Here's the thing. All irrational numbers are non-terminating, non-repeating decimals. So think about pi, because that's the one most of us know, right? Pi is approximately what?
3.14.
And what's the thing about this pi? If you were to continue going out, 3.1415, what would happen is it would go forever, wouldn't it? It would go forever.
Yeah.
And so in that case, it's non-terminating. It never stops, but it never repeats, which means that as you go out 1.414 and you keep going out, there's no pattern. There is no pattern at all to the way those numbers appear. None at all. You cannot establish a pattern. It's almost like completely random how those numbers keep appearing in the decimal. That's what makes an irrational number irrational. It never terminates, and there's no pattern to the numbers. So when you go back and look at all of these numbers that were rational, all of these, if you were to write them out, this would be 4, that's the number 4, right? So I could write that as 4.00000, and that goes forever, doesn't it? 0, 0, 0, 0, 0. But there's a pattern, right? The next number is 0. So it's still not irrational because it doesn't terminate, but it does repeat. Does that make sense? And then 1/3. What about 1/3? Well, that's 0.3333. It goes forever, doesn't it? So it never stops, but there's a pattern, right? There's a pattern. So in this number line between 0 and 1, we already established there's an infinite number of numbers, okay? We all agree there's an infinite number. But what I'm telling you now is that not only is there an infinite number of numbers, there's numbers in there that are not fractions, that are actually irrational numbers. Now, I only gave you 3 examples of irrational numbers, right? I've only given you 3 examples. The next thing I'm going to try and explain or get you to believe is kind of going to blow your mind, okay? And that's this. If you look at all the numbers between 0 and 1, okay? So imagine this experiment here. Take all the numbers between 0 and 1, you close your eyes, you reach in there and you grab a number. What do you think the probability is that you grabbed a fraction? So you know that there are fractions in there, right? There's a lot of fractions in there. And I just told you that there are irrational numbers in there also. So I'm asking you, if you close your eyes and reach in there and grab a fraction, what do you think the probability is that you have a fraction in your hand? What do y'all think? Probabilities go between 0 and 100%, right? Like either guaranteed or guaranteed not, or anything in between, right? So what do y'all think? What percentage chance do you think it is that you're holding a fraction if you just randomly reach in there and grab it?
100.
100%?
90, I would say 98%.
98, pretty high, but you know, there's some stuff that's not fractions in there. Any other? Would it bother you if I told you the probability of grabbing a fraction was 0? Would that trouble your mind? It should, but that's what it is. The probability of grabbing a fraction out of that interval randomly is 0, which should really bother you. Okay, that should really bother you, because we know there's an infinite number of fractions in there, right? There's an infinite number of fractions, but there's all this other stuff in there too that doesn't get credit. Your whole life you've been talking about numbers, fractions and integers, and you know, negative numbers, positive, and irrationals have just been kind of like this little side note, haven't they? Give you a few examples. I'm telling you though that there's so many more irrationals in there than rationals. It's hard to understand. So here's the best explanation that I can give you. Actually, I can share my screen. I think this, let me see if this will work. Okay, I just happen to have this as my screensaver. Can you all see this screen? This is a little tent.
Yes, sir.
And then here's the sky, right? This is obviously away from the city. You can see all the stars out here. So I want you to think about the number line, just the numbers between 0 and 1. And I want you to imagine that that's like this sky, okay? And everywhere you look out in the sky, you see stars, right? The stars are like the fractions. Do you see they're kind of everywhere, right? Like, seems like they're everywhere. It's like an infinite number of stars here, it looks like, right? That's the fractions. So what are the irrational numbers then?
The space in between?
The space in between, the black, okay? It's nowhere and everywhere kind of at the same time. Does that make sense? So if
Yes, it does.
If I ask you to close your eyes and then like point out into the sky, what's the probability that you're pointing exactly at a star? Like if you could follow like a laser line, right, what is the probability you're going to be pointing at a star? Well, essentially 0. You have to actually point, you have to aim, open your eyes and aim for it. Because if you don't aim for it, you're going to hit the black. Does that make sense? I hope that kind of makes sense. So
Yeah, it's a great analogy.
that's the best one I can use. So if you're ever walking on, you know.
So like the black space comes before like the stars, or you're saying?
Well,
Like
I'm
that?
saying the black space are the numbers that are irrational in the number line.
Yeah.
If you look in here, it's like you've got all these fractions in here. Those are your stars. But all the space in between is the irrational numbers. And it's almost like impossible to nail one down because they're there, but see, they're non-terminating, non-repeating decimals. So how do you ever like nail it down? Does that make sense?
Yeah.
It's really an abstract idea. It's really a tough idea. But what I'm trying to get you to understand here today, first thing I'm talking about, okay, this is actually based on something called measure theory. And it's something that we base all of our math on, is this idea of measure theory. But I want you to really be thinking about really, you know, like the whole idea of a number line and all the points on a number line is something we've taken for granted. It's a very complex idea. And we're going to need to be able to kind of think about it a little bit harder than we have in the past. We can't just be like, oh yeah, every number in there is a fraction. Nope, not every number there is a fraction, okay? It's much more complicated than that. So going back to this, is every number in here a fraction? No, okay? Now there's 2 types of infinity. I'm not going to talk about that today, but there are 2 types of infinity. And so the rational numbers are what are called countably infinite, and then the irrationals are called uncountable. I'll hit that on a different day, all right? I want to get to the next question. What is the number right to the left of the number 1? So I'm asking you, right there to the left of 1. What number is that? What do you think?
An irrational number? Or I don't know.
It's unknown.
Unknown? So you're saying you don't think there is a number right next to 1?
I think there is a number next to 1. I just think that it's nothing. We can't. It's so small we can't measure it, or we can't measure it with our normal person brains.
It can be just 0.99999 till.
0.9999. Okay, so yeah, I need a new page. All right, let's think about this. This is an important, very important concept right here. If we're looking at the number 1, I'm asking you, is there a number? Is there a number right to the left of 1 with no gap in between, right? So be right next to 1. Not 1, not the number 1, but something right next to it. Does that make sense? Think of it like lily pads. If this was the number 1, what would be the number right before it? That's my question. And one answer I've heard is maybe it's the number 0.999 forever. That seems reasonable. Maybe. And then is it Roberto? Am I saying it?
Yes, yes.
Roberto?
You can call me Robert or Delgado or anything like that. It's
Okay.
it's usually easier for people.
Okay, all right. So I think Robert was saying that maybe there is some number, but we can't quite wrap our heads around what it is. Like we know it's there, but we don't know maybe how to find it. I don't know, right? All right, so I don't want to drag this class on too long. Okay, I'd go on for like a week talking about this. It turns out, okay, there is no number right next to 1. There is no number that is the closest number to 1. There is none. Because if you think that there is, I can always find one closer. And then if we use that one, I can always find one closer than that. Let me show you. Let me do it this way. Let's say that you believe, here's the number 1. We'll put it on a lily pad. Okay, there's number 1. Let's say that you found some number right here and you're gonna, let's call it A, okay? And you were trying to tell me, hey everyone, A is the number that's right next to 1. Here's what I do to prove you wrong. I take your A, I add 1, and I divide by 2. In other words, I take the average of these two numbers. And the average of those two numbers will always lie in between them. Your average always has to be between two numbers. Unless they're the same number, right? Like, what's the average of 2 and 2? Well, that would be 2. But if they're different numbers, the average must lie between them, right in the middle of them. So then this number would be the new number that's closest. Does that make sense? And then if I say, okay, well, that one's closest, then I can just do the average again. And I can do that forever. Yeah. Now, I didn't see who said 0.99999 forever.
Bellum.
Bellum, okay, so that's a good, what do y'all think about Bellum's idea? 0.999 forever. That looks pretty damn close to 1 to me. Right? Yeah,
Yes.
okay. So ready?
Yeah.
I'm gonna try and blow your minds now. You ready for this? Here we go. Bellum. Everybody here, follow along. All I need you to do right now is just agree or disagree with me. Okay, everything I'm gonna do is arithmetic. Okay, so I'm just going to first start out by doing this. I'm gonna say let x be 0.999 forever. Okay, got it? I've defined what x is. We happy? Okay, now, then what would 10x be? So what happens when you multiply a number by 10? What happens to the decimal point?
It's
What?
the decimal point is moved back.
Moves to the right one. Do you all agree?
Mhm.
Okay, so if I multiply that by 10, I get 9.999 forever. Yes? All right. Now, I want you to consider two different ideas now. Purely from an algebraic standpoint, forget what x is. If I told you to take 10 x's and subtract an x, how many x's would you have?
9x.
Not a trick question, 9x, right? Right? But in terms of our problem, 10x is 9.999, right? And if I subtract from that x, that's 0.999 forever. What would happen if you take 9.999 forever and subtract the 0.999 forever? What are you left with?
9.
9. Which means that that 9x must be 9, right? But if 9x equals 9 and you divide both sides by 9, what do you get?
One
That x is what?
or
1.
X is 1. Which actually means that 0.99 forever, Bellum, is actually the number 1. It is the number 1. It's not the number right next to 1. It is the number 1.
I am so confused right now.
But don't worry about it. Don't worry about it.
My mind's being blown too much. You gotta slow
Yeah,
down.
I understand. I'm just trying to get you to kind of like at least get your mind turning, all right? Get the gears going. It turns out that the number 0.999 forever, which seems like a really good candidate for the number right next to 1, is the number 1. And so that's not it, unfortunately. Now, look, everything I talked about right now is not something you should have learned in a previous class, or you shouldn't be sitting there and go, oh my God, I've walked into a fire here. I'm just trying to start to get your brain turning and thinking critically about things instead of thinking about everything as like a monkey see, monkey do. Show me a formula, I will apply the formula like robot, okay? I want you to be thinking critically. All right, so back to this. How many numbers are there? Infinite number. Are they all fractions? No. What is the number right to the left of 1? There is no number right to the left of 1. All right, well, if there's no number right to the left of 1, it brings up this very, very troubling part of math, and especially calculus. And that is, what does being close to a number mean? So right now, would you consider me to be close to you physically, in physical space? Am I close to you right now?
No.
No.
Everyone's saying no.
It depends
Depends on what?
how much space, like, because there's a lot of it.
Yeah. So like,
Because
I would say, personally, I would say that y'all are almost like invading my personal space right now. That's how I feel. Y'all are almost too close to me relative to the distance from me to the sun, right? If my scale is me thinking about from me to the sun, right, then y'all are very close to me. Would you agree?
Yes.
yes,
Okay. So it's relative. Closeness is relative. And that is a problem in mathematics, because if you think about the numbers between 0 and 1, right? And I tell you, hey, y'all go pick a number. Go give me a number that's close to 1. Somebody give me a number close to 1 right
2.
2. Okay, that's close to 1. Somebody give me a number closer to 1.
1/2,
A half? Closer.
1/4,
I'm trying to get close to 1.
1.1.
1.1. Now is 1.1 close to 1? It's relative.
Compare.
It's relative, right? Because I think 1.1, yeah, it's close to 1, but isn't this number closer? 1.00000000000000000000001. Isn't that number closer to 1 than 1.1?
Yes.
Yes. So would you make an argument that that's close to 1? You could, but then someone could say, what about 1 point and then a million zeros and a 1 at the end? Wouldn't that be even closer? And you're never going to run out of like the number of zeros. Does this make sense? It's the idea of closeness in math is very difficult to wrap your head around. All right. And that's what makes rigorous mathematics very difficult. In this class, we are not going to get rigorous with mathematics. We're not going to do what we call delta epsilon proofs and trying to prove the theorems that we're using. In this class, when we talk about close, we're going to first have a respect for the idea that closeness is abstract. But we are all going to agree that when if I ask you to find a number close to 1, 0.99, that's pretty close. All right, 0.99. Or you could say 1.01, that's pretty close to 1. Understand? We're going to wave our hands at it because this is a very, very tricky subject. And it's because there's an infinite number of numbers in there. You're never going to run out. You can build your way up to 1 and never run out of numbers. You can just get it closer and closer and closer and closer and closer and closer and never actually get there. So, all right, I've taken 30 minutes to just get you to try and think abstractly. I will revisit this as we proceed. For now, let's take it, box it up, back burner with this, all right? I have another little exercise. This one should be a little bit easier to wrap your head around. What I've done is I've given you the graph of a function, and I'm asking you to answer numbers 1, 2, 3, and 4. So take about, I don't know, 30 seconds to a minute to jot down the answers or have them in your head. We'll go 1 minute. Okay, so let me just restate because, I want to make sure everyone knows kind of the rules we're playing by here. That in the syllabus and in the orientation video, I do say that I do want everyone to have their videos on. If you can't have it on every day or you want to turn off a part of the class or whatever, that's fine. Like just now, I just turned off mine for a few minutes. I was blowing my nose. Didn't want y'all to see or hear that. So if you need to, that's fine. I understand. But that's part of your participation grade. So I just want to make sure everyone understands that in case you missed it. But I'm also going to call on people throughout the class. I have a list over here on one of my computer screens. This is kind of how I try and do attendance. And I'll just kind of randomly call on people. It's not going to be in any particular order. And what I'm hoping won't happen is that I see someone that every time I call on them, they're either not here or they've just got their camera off and they're just their name and they're not responding to me. So I want to make sure that y'all are engaging in the class. And look, there's no shame in being wrong here. Okay. I actually want you to make mistakes. That's how we learn in math. We make mistakes and we learn from those mistakes, right? And most of you have to take Cal 2. So, right? A lot of you probably do. So in Cal 2, you can only learn by making mistakes. Like there's no easy path through. So, if I call on you and you're not sure, don't feel ashamed. Okay. No one's going to leave here and be like, Jose, man, that guy, oh man, he's a complete, look, we're here to learn, right? And most importantly, it's your education. Your thing about it is like, I'm here to help you. Cares about what everyone else thinks, right? And then when other people see you not, get hung up, then it makes them feel a little better. Like I'm not the only one, So I'm not trying to embarrass people. All right, so here we go. I'm just gonna start going through this here. If I call your name and I say it wrong, or you want to go by something else, let me know and I'll notate it here. All right, so Al-Hawi, am I saying that right? Al-Hawi? I don't see that student here. Okay, so I'm just going to go in alphabetical order today. Landon, oh wait, what is it? Shams? I'm sorry, Shams? No, Shams, no. Okay, Landon, where's Landon?
Yes, sir, I'm right here.
Hey, Landon, we met the other day, didn't we?
Yes, we did.
Okay, Landon, so what do you feel about, I don't know, you got all four?
Well, you're talking about the question, right?
Yeah, I want to know what is f of -2.
Okay, I have no idea.
Okay, good.
I'm pretty confused on like, is it asking to find the like coordinates of like where like the core, or is it asking for coordinates or is it asking for the actual functions of the graph? That's what I'm confused about.
So what this is asking for is it's asking for you to look at this function.
Mhm.
And by the way, everyone, it is a function because it passes the vertical line test, correct? If I draw
Yes.
vertical lines, I never hit the graph more than once. Okay, so it's saying here, what is the value of the function at -2? In other words, this is my input, or if you'd like, this is the x value. And what it's asking for is the output of the function, which is the y value.
Oh, okay.
Okay, so if you go to an x input of -2, which here's our x-axis, go to -2, what is the output value of the function there?
Oh, okay, I see, I see. Then in this case, it would be 0, no, it would be +1 or +2.
So where are you getting that from? Are you getting it from right here?
Yes.
Okay, so this is an open circle. Do you all see that, everyone?
Mm.
If you continue up, do you see it's a solid dot?
Oh, okay, I see.
Okay.
It's-
Oh, good, Landon. This is exactly what I want, because if you would have known the answer is 4 and we moved on and someone didn't understand it, then it doesn't help them, right? So we look at -2. We basically are looking up and down. We're looking for the function, saying where's the function defined. So we move up. Oh, wait, that's a circle. It's open, right? So there's no point there. We keep going. Oh, up here at 4. That's our output value, 4. In other words, you could look at that as a point. It's the point -2, 4. Where -2 is the input and 4 is the output. Good.
Oh, okay, okay, I get it then.
Okay, you want to try the next one then?
Yes, then it would be, it would be 3 then, right?
It'd be 3, correct,
Yes.
right? Because if you go to 0 on the x-axis, the output value is 3, not this one, because it's an open hole. And you go here, boom.
Okay.
All right, good. Valerie, you want to go next? Is Valerie here?
Oh, yeah, I'm here. I'm right here.
Okay,
Okay, so F1, right?
the f, yes. I'm wanting to know the function's value at 1.
Oh,
So if you go to 1 on the x-axis and look up and down on the graph, where's the y value of the function?
what would be 3?
It'd be 3. Yeah. Now I didn't put a dot there, did I?
No.
But it's implied that it's there, right? These are all dots. I mean, every one of these is a dot. So there is a dot there, even though it's not written. Good. So that's 3. All right. You want to do the next one, Valerie? Let's go ahead.
Okay.
So what's the function's value at 3?
At 3, so
It's a trick question.
4.
So where are you getting 4 from? So I'm looking up and down here. I'm trying to see, do I have graph? Do I ever have a point? Well, this is an open circle, right? So I don't have anything here.
Yeah.
And if I keep going up, I don't see any dots, do I?
Infinity.
No, there's nothing up there. I didn't put, well, at least on this graph, you can't see it. What would we say? Who knows what we'd say in this case? If we go to the value 3 and there's nothing there.
Empty set.
It does not exist.
Does not
Undefined.
exist.
In
Empty
F
set,
undefined.
undefined. So technically, the correct language we use here is that it is undefined. Now, I heard does not exist. We will reserve that for something in a little while. Okay, so here we put undefined. Okay, so again, when you're looking at the graphical function and you're trying to figure out the value of the function, you're basically just going to the x value, looking up and down and kind of seeing, do you have a point somewhere, and figuring out how high that point is. If there is no point, then it's undefined. Yeah? Okay, so I have another couple of questions I want to ask here. What is f of 2.9? And let's go with Matthew, Cantu. Is Matthew here?
Yes, I'm here.
Okay, what do you think? What's f of 2.9? Can you tell from the picture?
2.9. I want to say it's 3.
Yeah, so it looks like when you go up here, 2.9 is somewhere around here, you go up here. And so I have a hole there, right? Does
Yes.
everyone understand that that hole represents what's happening at 3? But it's implied that to the left of 3, it's just kind of following this pattern of what's happening over here. So at 2.9, which is somewhere in here, 2.9, you go up and you look at the y value, there's a point there. And so we'd say that that's 3. I agree, Matthew. Now, Matthew, how about this? What would f of 2.99 be?
I feel like it'd still be 3.
Still 3. See, I'm getting closer. I'm getting closer to 3. Do y'all see that? 2.9 is close to 3. 2.99 is even closer. What would f of 2.99999 be? What do you think?
The same thing, 3.
3, right? It's going to continue to be 3. The thing is, as soon as I get to 3, though, it's undefined. Yes?
Yes.
We good, everyone? We understand? Okay, now I want to change it up a little bit. We'll go with, let's see, we already did Robert Delgado. You say you don't mind going by Delgado? You're good with that?
Yeah, I'm good with that.
Okay, I have a really good friend from grade school and high school that is Delgado. I mean, I know, so that's easy for me. All right, Chloe. Is Chloe here?
Yeah.
There's Chloe. I'm looking for you. Where are you? Oh, there you are. Okay. So Chloe, Chloe, I have a question for you.
Yes.
Using the same idea, what do you think f of 3.1 is? So I'm going to
Value
zoom in
less
here a
than
little
3.
bit. Say again?
A value less than 3.
A value less than 3. Perfect answer. I mean, that is exactly what I was hoping you would say, something like that. So 3.1 is over here somewhere, right? And if you plug that in, you're somewhere over here. It's a value that's less than 3. Do you all agree with that?
Yes.
So maybe like 2.9 or something like that. Yes? 2.9. We can't really tell exactly what it is, but I like the answer. Chloe said less than 3. So I'm just going to say that this is less than 3. It's more of an idea, a concept here. Okay. Chloe, we're sticking with you. What is f of 3.0001 then?
I'd say the same thing. It's not.
Okay.
Because that's
So
a 3.
I've gotten closer to 3, right? I've gotten even
Yeah.
closer to 3, haven't I?
Yeah.
And so if I'm even closer to 3, like somewhere around in here, and I plug that in, that number is still smaller than 3, isn't it?
Mhm.
But it's also bigger than the previous one, isn't it?
Yep.
So Chloe, as I kind of move, you think about it this way, as I start to kind of move from right to left along this graph, those values of the function, the values of the function are smaller than 3 and they're getting closer to 3, aren't they?
Yeah.
Yeah. And if I come in from the right, from the left side, the values of the function are 3, aren't they?
Mhm.
Everyone got that? Everyone understand that? This idea is critical in this class, okay? I know it seems kind of odd. It seems very strange the way we're looking at things now, but trust me, this is what we need to proceed. All right. Let me see if there's some, here we go. This will be a true test here. Let me copy this and paste it down here. All right, I want us to look at this function again. And I want us to focus our attention on this part right here. All right, there we go. All right, so I'm going to put someone on the spot here. Leonard, where's Leonard? Leonard, no? Looking
Here.
for- There you go, okay. Okay, Leonard. What is the value of the function at -2, Leonard?
That would be,
I think it was
there's no-
4. Sorry, it's off the graph. Hold on, let me. go.
Yeah.
Sorry. It was 4 up here. Sorry, it was 4. So this is 4 up here, which means this is 3.
Mhm.
This is 2, this is 1, this was 0. Okay. So Leonard, f of -2 is 4. We're all good with that. We started with this, yes?
yes.
Okay, so Leonard, here's my question to you. What is the function approaching as I plug in values of x that are getting close to -2 from the left side? See if you can wrap your head around everything I just said. What is the function's values? What are the function's values approaching as I start plugging in numbers for x from the left side of -2? What is the function doing?
Rising up, so it's like -2.
So I'm from the left side, I'm over here, right? Plugging in some
Yeah.
numbers. I'm
Mhm.
there, and then I go a little closer, and then I'm there. You said they're rising up, right?
Yeah.
Okay, can you tell me where they're rising toward? What are they rising toward? What y
-2.
value are they approaching?
-2.
That's what the x is. The x is approaching -2, right? Down here, if I'm plugging in numbers, these numbers are getting closer to -2, but what are the y values approaching? What are these values approaching?
Oh, because the open circle confuses me, so I'm like, nothing. I was gonna say that.
Okay, all right. Let me put it a different way. Leonard, if I'm approaching -2 from the left side, right? If I'm approaching -2 from the left side, I want you to imagine that you're a person standing on this graph, okay? And as you move your x value towards -2, you must go up as you do it, right? So you're like climbing this hill. Now, as you climb, what height are you approaching? What y value are you actually getting closer and closer to?
2.
2, is that what you said?
Yeah.
2. Now, Leonard, will you actually ever get there?
No.
No. Does everyone understand that? This is a big concept. As this little hiker is climbing up this hill, the y values are getting bigger and bigger, 1.8, 1.9. As you get closer and closer, the closer you get to -2 from the left, the closer the y value gets to +2, but you never actually reach it, right? You never reach it. You never reach 2. You'll never get to it. Christian, are you there?
Yes.
Okay, Christian, does that kind of make sense, what I just did?
Mhm.
Then I'm going to ask you the same question, but I want you to imagine coming into -2 from the right side instead.
Mhm.
So you're now a hiker. You're climbing on the function. You're approaching -2 from the right. And you're walking along the function here, right? And you're trying to move closer to this -2 value on the X. Where's your hiker's, where is he approaching? What's the Y value approaching?
Y is approaching 4.
It's approaching 4, right? Everyone see that? As you pick points that are getting closer and closer to -2 from the right, this hiker climbs up and these Y values approach and approach and approach and approach, and they get closer to 4, right? You'll never actually get to 4 unless you're standing on -2, right? If you actually stand on -2, you will reach 4. But if you're a little to the right of it, you'll be approaching 4. If you're a little to the left of -2, you'll be down approaching 2. Are y'all with me on this or not? We're going to need a few more examples, trust me. But if you're following this, you know, it's good. That's a good thing. I'm going to get to my notes. It's time for me to start talking about notes. So all of these notes are in Canvas. You can bring these up later. We are going to start in 1.3. We're starting with this idea called the limit of a function, which is exactly what I just kind of tried to give you an introduction to. So I want us to look at this. Look at this graph. Okay, here's a graph of a function. This is a polynomial function. It's the function -x³ plus 4x plus 4x squared. All right, there's the graph bit. Nice, pretty polynomial. Great. What I'm doing here is I'm asking you to consider first what's happening at 2. It's hard to see. This is 1, 2, 3, 4. Here's 5. Right, this is 2, 4, 6, 8, 10. Okay, there's my graph. First question is a college algebra question. What is f of 2? That's a college algebra question. Kevin, you want to help us out? Where's Kevin? Kevin, hey, how's it going, Kevin?
It's going good. How about you?
I'm trying to help everyone understand this. This is, you know, we got to get our heads around this. So I'm doing okay.
Okay. Can you repeat the question again?
I want you to tell me what happens if you plug 2 into this function, just by looking at the graph. What is the Y value when you plug 2 into the function?
The Y value is 8.
Is 8, okay? All right, great. So would you say that's pretty basic, easy idea, Kevin?
Yes.
Yeah, you just go, you look at the graph, you say, oh, plug in 2. Well, look, I have a point there, that's 8. Okay, there's the value. That is college algebra, everyone, okay? That is like, you ignore everything that's going on, and you just go, oh, look at 2, go see what the graph's doing. Oh, it has a value of 8. That's what you do in college algebra, all right? That is not what calculus is about. Okay, that's not what calculus is about at all. Calculus is actually the other way around. I don't care what's happening at 2. Okay, I do not care at all what is happening at 2. In fact, I want you to ignore it completely. And instead, I want to ask the question, what is the function doing as I get close to 2? Close to 2, right? That's the question. And when I say close to 2, there's 2 different ways that I can do that. One way is to come in from the left-hand side and talk about what the function's value is approaching. Or I can come in from the right-hand side and talk about what the function's value is doing as I get closer and closer to 2 from the left and from the right. Does that make sense? Now, why we're doing this is not going to be clear at this point. Like, why do we do this? This is stupid. You know, trust me, it is going to allow us to do some pretty crazy stuff. All right. But we first have to wrap our heads around the idea of looking at what a function's behavior is, not at a point, but near a point, near it. So let me ask Jose, did I already do Jose? No? Jose, where's Jose?
I'm here, sir.
Okay, so Jose, looking at this function, if I look at the number 2 here on the x-axis, if I move along this function and approach 2 from the left, can you tell me what the function's value is approaching?
The function's value is approaching,
Keep an eye on that number, everyone. Go ahead.
the function's value is approaching 8.
It's approaching 8, isn't it? Look, as I get closer to 2, look at what's happening. I'm getting closer to 2. Do y'all see I'm at 1.94? That's pretty close to 2, right? And look at the value, 7.775. I'm getting pretty close to 8. I'm trying to get closer to 2. Y'all see that changing? 1.978. It's getting closer to 2. And look at this number is getting closer to 8. You can see it from the graph though, right? That hill is trying to reach 8. I don't care what's happening at 2. Kevin already told us at 2 it's 8. I don't give a shit about that. I care about what's happening from the left. Okay. Now, James, what's happening from the right? So let me bring it in. Where's James?
Hello.
Okay, James. So I'm coming in from the right. No, I'm not. Here it is. Okay, I'm coming in from the right. Keep track of the black number here, right, James? So what is it doing?
It's rising
It goes up and
then it starts to fall.
where is it approaching now?
It is now approaching 8.
8, right? So from the left-hand side, the function, Jose said from the left, it's approaching 8. And then James said from the right, it's approaching 8. And Kevin said at 2, it is 8, right? It's doing everything it's behaving very, very nicely. This function does kind of exactly what you hope it would do. It behaves well, right? If you go to any point on this graph, go to any point, then as you approach from the left and from the right, the function is headed to the same point that it's defined at, right? I think the best way to see this is to give you a different example. Here's a new function. Here's a new function, everyone. It's hard to see this. Now, I'm giving you the function, okay? But I'm covering the whole function up, except for what's happening at 2, right? That's all you can see is what's happening at 2. So is it Hale or Hallie? I'm not sure how to say this.
It's Halle.
It's what?
Halle.
Halle. Okay, so Halle. I'm going to kind of change that here. Hall like a hall, right? Hall.
Yeah.
Okay. Yeah, I think I'll get it that way. No, I might not. I'll try. I'll get it eventually. Okay, here we go. Halle. What is the function's value at 2?
8.
8. Everyone got that? So all Halle has to do is look at 2, look up, and look for a solid dot. And there it was at 8, right? Here it was at 8. Boom, boom, boom. There's the dot. Okay, great. Wonderful. Well, I told you, this is not what calculus is about. That's algebra. So I want us to now ignore that and switch it. Now I'm showing you the rest of the graph. Do you see that? I don't care what's happening at 2 anymore. And now I want to know what's happening from the left and from the right. Those are 2 different questions. So Halle, let's stick with you. What is the Halle, what is the function approaching? What is the function's value approaching as we approach the x value 2 from the left? So get your little climber here and tell me where that thing's headed.
Where the y value is approaching?
Where the y, so when I say what is the function's value approaching, I mean the y value.
Okay.
Okay, as
So-
x approaches, so we're approaching 2 from the left, the x is approaching 2, and you are going to tell me what the y is approaching. What do you got?
It's approaching 8.
It's approaching 8, right? That's what's happening, everyone? It's approaching 8 from the left. Okay, good. Now, we move on. Nicholas. Nicholas here?
Yes, I'm here.
Okay, Nicholas, how about approaching from the right? What is the function doing as we approach from the right? It's kind of hard to see. I'm going to kind of zoom it out there. Can you tell?
It's approaching 8, but never made it to 8.
Is it going to 8? Look at this blue dot. Look at this blue dot. As I come in from the right, is it going all the way up to 8?
No.
No, it goes up and it looks
it
like
goes
it's coming back down and it's dropping down. And what does that look like it's getting closer to? Can you tell? This is 2,
4.
this is 4, this is 6. Yeah, it's getting closer to 4. Do you all see that? It's getting closer to 4. Now, does it ever get to 4? I don't care. It's about what it's getting close to. This is why I said in the beginning, the idea of closeness is weird. We're going to have to kind of wave our hands at it a little bit. The general idea here is that from the left, the function is headed up towards 8, and from the right, the function is headed towards 4. It kind of goes up and then drops back down. Is that clear, everyone? Let me take this thing out of here and just kind of clear everything out. There's the function. You can see that at 2, it's 8. From the left, it heads to 8. From the right, it heads to 4.
And do you write it like that with those?
I'll
things?
get the notation. I'll explain the notation in a minute. Right now,
Yeah.
we're just trying to get the concept down. I'll tell you
Okay.
how we're going to write it down in a minute. Okay, let's see. Is it duck?
Yes.
Okay. Y'all just let me know if I need to pronounce anything different or say something different or whatever. You just let me know.
Yeah, say it right.
Okay, Duck. Here's a function. And my question to you first, what's f of 2? Can you tell?
Number 6.
Say again?
6.
6. Everyone see that? At 2, open hole, nope. Here, 6, here, 8, right? But this is the solid dot. So Duck is saying at 2, the function's value is 6. Got it? Yes? Now I'm going to show you the graph. Let's cover the middle and show you what the rest of the graph looks like. So Duck, what happens as we approach 2 from the left? Where's the function headed, Duck?
8 headed to number 8.
It's headed towards 8?
Yes.
Uh-oh. What happened here? Something's going on.
Or 6.
Hold on. Sorry, I said 8. There's something going on with my thing. Weird. It's not working. Interesting. Okay, it's all right. I'll just have to use my pen. So Duck is saying that from the left, it looks like our function is headed towards, I had moved it on you, Duck, sorry. So this is actually headed towards 8, right?
Right.
Never actually gets there. Or who cares what happens there? It's just getting closer to 8. Duck, what about from the right?
It get closer to 4.
It's going to be headed towards 4. So as we come into 2 from the right, the function's value is headed towards 4. Y'all understanding this idea of a left side and a right side? Don't know why it's not. Let's see here. Yeah, all right. So let me go back. I'm going to give you something for you to try. All right. All right, here we go. So I'm going to say this is 1, 2, 3. And let's just say this is 1, 2, and I'm going to just draw something for you real quick. Don't worry about copying this all down. Okay. Ready? Ash, you're up.
Yes.
Okay, Ash, you get the algebra questions first. So the algebra question first, Ash, is what is f of 1?
F of 1 is 2.
2. Everyone got that? You plug in 1 to this function. Oh, we have a dot right there. The function's value is 2. Good. Yes, everyone? Okay, Ash, what's f of 2?
F of 2 is 0.
0. Good. So at 2, the function's value is 0. Okay. What's f of 3?
Undefined.
Undefined. Good. Okay, those are all college algebra questions. You're just looking at the graph, looking up and down, looking for points. That's it. Right? Good, Ash. Sophia. You here? Sophia.
I'm here.
There you are. I'm looking for you on my screen. Okay, Sophia. So I'm going to ask you the first question that's more of the calculus question. I want to know what's happening to this function as we approach 1 from the left. So let's see, without using any proper notation, I just want to see if you understand that word question that I just gave you. So can you tell me what
It's
this function
approaching
is?
1.
Wait, say again, I'm sorry.
It's approaching 1.
Approaching 1. So I asked Sophia, I said, hey, what happens when we approach 1 from the left? Sophia said, oh, we're moving along this graph and we are getting closer and closer to a y value of 1. Now, Sophia, it doesn't matter that we never get to it, right? It's that we're getting closer to 1, right? Okay. Sophia, let me ask you to continue. What would the function's value be approaching as we approach 1 from the right?
It's also increasing to approach 1.
It's also increasing to approach 1. Now, it never gets there. Again, it never actually gets to 1, but the closer you get, the closer you move in, the higher and higher it gets. Close to 1, never reaching there. Okay, very good. Let me see, Aaron.
I go by red.
Yeah, I see that's on the screen. Okay, so you're gonna go by red. So I'm going to just get rid of that. Okay, red. All right, red. So how about, are you understanding first? Are you?
Yeah. Mhm.
Okay. So I would like you to look at what's happening at 3. So what is the function's value approaching as we approach 3 from the left?
It's approaching 2.
It's approaching 2. Good. So we're looking at 3. We're approaching from the left. The function's value is approaching this y value of 2. How about from the right, red?
It's approaching like 0.8.
Oh, I missed it. Yeah, I'm sorry. I messed up. Okay, this right here was supposed to be approaching, but you said right. Let's go with 0.8, okay? Because it's not quite, it was supposed to be 1 up, 1 more just to make it easy, but it's approaching almost 1, right? Okay, I think we're ready to get formal notes here, like in terms of notation. All right, so this is all again written down, and you can print this out and look through it again. The idea is this. The idea is very basic in terms of if you're given some function, here's some value a. We've been using 2 a lot, approaching from both sides of 2, but it can be any value. And then you've got some function, I don't know what it's doing here. It can be doing whatever, right? Who cares? We have this idea of coming from the left, and we have an idea of coming from the right. And what we're doing is we're approaching this value a. So we're letting our x values get closer to a, our x values get closer to a, right? And what we're asking is, what is the function doing as you do that on the left and on the right? So the notation that we're going to use for this is this right here. If we want to be talking about what is the function doing as you approach a from the left, we use this thing called the left-hand limit. And here's the notation we use. Now, I'm going to write this down on a separate page. That's what we use if we have a left-hand limit. The other one is the right hand. Let me clear this. I'm going to copy. So I'm just going to paste this in here. All right, so the 2 notations we have are here. The first one looks like this. You write limit, it's L-I-M. That stands for limit. X with an arrow going to A, then a little negative sign to the top right of the A. The negative sign, think of it like a number line, right? The negative numbers are out here, right, on the left side. So this little negative sign means, hey, I want to approach A from the left side, and then I want you to tell me what the function's doing. That's the way we say that, right? That's the notation we use to say, hey, what is the function doing as you approach A from the left? And that is called the left-hand limit. And if there is an answer, the answer will be L, some number. And the only difference between that and coming in from the right is that we change this little minus to a plus. That's the only difference between the 2 notations. That is the formal calculus notation for me asking you that question that I've been asking you as we've gone through the class, okay? So let me do another one. Do a real quick one here. Do a graph. Say that's 2, 1. All right. Here we go. First part. What is the limit as x approaches 1 from the left of this function? So that's my first question that goes to Alec.
It's approaching 2.
It's approaching 2. So I'm approaching 1 from the left because there's a negative sign here of the function. So Alec went, okay, gonna walk. Here's 1. We're approaching from this side. So we're walking along here, coming. And our y value is approaching 2. Good. B. Let's do the limit as x approaches 1 from the right-hand side of the function this time. And let's see, I'm trying to get through everyone here. Let's see. Was it Devin or Devon? I forgot. It's what?
Devin.
Devin, okay. I
Yeah.
called on you earlier, didn't I? Or you?
Yeah.
Called you earlier, okay. I didn't mark it down. Enrique?
Yes.
Okay, what about this one? What's this?
That would be 1, approaching 1.
1, okay, good. Part C, we'll stick with Enrique for C. What's f of 1, Enrique?
0.
0. Okay, so that's an algebra question, right? This was back to algebra. Hey, what's happening at 1? Oh, the function's spitting out 0. The limit from the left, oh, that was 2. The limit from the right, that was coming in this way, that was 1. Right? All right, so D, E, and F are limits as we approach 2. 2 from the left. The limit x approaches 2 from the right. And then let's let the last one be f of 2. So take a second to see if you can get those. And then I think David is going to give us the answers. Are you ready, David?
Yes.
Yeah, you ready to go?
Yeah.
Okay, so what is the limit as x approaches 2 from the left of this function?
0.
0. Okay, so coming in, moving along this.
Yeah.
Okay, and it's 0. How about from the right?
It's approaching 1.
1. Okay. So it's approaching 1. And then what about f of 2?
It's 0.
0. Good.
I have a question.
Yes, good. Yes.
So on E, should we write it undefined but later or no?
What is what undefined? For E?
Yeah.
Okay, I'm glad you asked that question. The limit is asking what your function is approaching, right?
Yeah.
It is not asking what's happening at that point.
Okay.
Okay, so what you're saying is, hey, I'm getting closer. Your answer was 1, right?
Yeah.
And that what you're saying is, as I come in from the right, I'm getting closer and closer and closer to 1. The fact that when I get to 2, when you actually get to 2, it's undefined, well, it's not defined to be 1, it's down at 0, is irrelevant.
Okay.
It just ignore everything that's happening in here.
Yeah.
Ignore it. So if you see a limit, you're ignoring what's happening at the point and just thinking about what's happening from the left and right.
So ignore it.
Okay.
Yeah.
Now this is the fundamental concept of the limit graphically. We are looking at the graphical meaning of the limit. So if we go back to the notes, we have this idea, this new notation, left and right hand limit. And then we have another limit called, well, just the limit, and it doesn't have a plus or a minus on it. So look at that notation right there. So you know that if I put a minus there, right? If I put a minus there, I want you to come in from the left, right? That's what that means. And if I put a plus here, that means I want you to come in from the right. Are we good with that idea? So if I don't put anything there, what do I want you to do? Well, what I mean by that is I want you to come in from both sides. Check both sides and tell me if they go to the same place. So a minus means from the left, a plus means from the right. Nothing there means check both sides, and to give me an answer means they must match. So I'll give you an example. If I give you this function, let's say it does this. Let's say that this is 2 and this is 3 up here. All right. If I ask you right now, what is the limit as x approaches 2 of this function? Do y'all see I do not have a plus or a minus, right? That means you have to check from the left and the right, and that they must be the same answer for you to give me an answer. So what happens from the left? Where is it headed? Let me see. I think we got through everyone. Oh no, Shams wasn't here earlier. Shams, you doing okay?
Hi, yes, I'm here.
Am I saying your name okay?
Yes, you're saying it correct.
Okay, Shams. So are you following along? I think you are from the look of it.
I am, but just a little confused. I already watched what I missed.
Okay, well, let's see if you got this. I'm asking, what is the, oh, where's my cursor? Come here. There it is. Okay, so when I put this notation, limit x approaches 2 of this function, that means I want you to approach from both sides, right? So
Yes.
first come in from the left. What happens to this function is we come in from the left of 2,
Oh.
trying to approach 2 from left. What is the function's value approaching?
2?
2, yeah, it's headed to 2, right? Now come in from the right. What is it?
It's also going to
It's
2.
also 2, right? They're both going to 2. So the answer here will be 2.
Okay.
Okay. Now, what is f of 2? College algebra, right? No limit anymore. So what's happening at 2? What's the function value?
So when y equals 2?
When x equals 2.
Oh, when
what is
x
the
equals
y?
2, it's 2. Right?
Nope, this 3.
Oh, okay, yeah, it's 3.
Yeah, so at 2, it's 3,
Okay,
right?
yes.
Everyone good with that? I'm going to give you another example, everyone, just so you can see, what about this? What if I had the same basic idea like this, but now I do this? And now I ask, what is the limit as x approaches 2 of this function? And I'll take a volunteer because I think I have gone through everyone today. So who wants to volunteer their answer to this?
It can be undefined.
Say,
It can
Bella?
be undefined or rather like an average of both.
Yeah, so look, everyone, from the left, you're getting what? What are we getting if we come in from the left?
3, no, 2.
Oh, I didn't label it, sorry. Sorry,
Yeah.
I should label it, you think? Okay, so if I come in from the left, it's headed to what?
2.
So the limit, if I approach 2 from the left, this is the left-hand limit, I get 2. Now, if I do the limit as I approach 2, go ahead, Bella, from the right, what do you get?
3.
You get 3, right? And notice these are not the same, right? So from the left, I'm approaching 2, from the right, I'm approaching 3. For this limit to be there, for this limit to actually exist, these two numbers would have to match.
Yes.
In which case they don't. So what we write is this. We don't put undefined, we put does not exist. Now I will abbreviate that from here on out, DNE. DNE for does not exist. For a limit to exist, you have to have the same from the left. The function has to be going to the same place from the left and the right for a limit to exist. Okay. All right. Let me pull something up real quick. Give me just a moment. Take a 30-second breather. All right, this is a problem I just pulled directly from an exam that I gave last semester. Let me look at it. I forgot to pull the actual question. No. Yeah, I'll just do it on, okay. So here's what I like. Here's what I'd like for you all to do on this, just to see if you understand. I'd like for you at -4, I want you to find the limit as x approaches -4 from the left of this function. That'll be part A. Part B, limit x approaches -4 from the right of this function. And part C, what is f of -4? Once you do that, I want you to do the same exact questions, but we're going to change it. Make this a little smaller. I want to change it to +4. All right, see if you can do those 6 problems in the next, I don't know, how long should that take? What do you think? How long do you think is an appropriate amount of time for that?
2 minutes.
2 minutes, the most, you think? Yeah. All right. Take a minute or two. We still have another 12, 13 minutes left in class. Okay, everyone. Feel like you got something? Who wants to volunteer?
I will.
Go ahead.
Answer all. Do you want me to answer all of them or just some?
How about ABC?
Okay, so for A, I got 5. For B, I got -3. And for C, I got 2.
What do y'all think? Does that seem right?
Yes.
That is correct. From the left, as we approach -4 from the left, it's approaching 5. We approach -4 from the right, it's approaching -3. And at -4, the value of the function is 2. Good. Who wants to volunteer D, E, and F?
I can try.
Go for it. What you got?
For D, it would be -2.
Good. From the left-hand side, we're approaching -2. This one is the one I'm interested to see what you do. Go ahead.
For E, it would be in infinity. I would
Good.
say.
Okay. So look, everyone, we actually almost look at this as like a vertical asymptote. And the function is like taking off, right? And it's going down and down and down and down. The closer you get to 4 from the right, it dives down to, now you said infinity, it should be negative infinity.
Negative
This is
infinity.
going
yes.
down.
Yes.
Good. Negative infinity. It's the first time we've seen that. Negative infinity as an answer.
Mhm. And for F, I put undefined.
Undefined. Undefined. And that's because at 4, there's no solid dots anymore.
Mhm.
Does anyone have any questions over that? That is
No.
all okay? Okay. Trying to move this over just a little bit. There we go. All right. So the next thing I want us to look at. No, that's not going to work. So far, everything I've done is I've shown you pictures, right? And I've said, hey, what's this limit? What's happening as we come from the left to the right? Instead of me giving you a picture, I'm going to give you the conditions and you're going to draw me the picture. This is backwards from everything we just did. This will be our last example of the day. So for this example, I want you to sketch a graph F such that these conditions are met. All right, here we go. First condition that we have to have is that f of -2 must equal 4. The next condition is that the limit as x approaches -2 of this function must be 2. The next condition is that f of 1 must be -3. The next condition is that the limit as x approaches 1 from the left of this function must be -3. And the last condition is that the limit as x approaches 1 from the right of this function must be 4. So I'm going to give you about 5 minutes to see if you can draw me a function that all 6 of those things are true. Now, everybody's picture is going to be a little bit different, all right? Everyone's drawing is going to be a little bit different because we have some freedom here. But we should all have those 6 things be true on our graphs. I recommend, well, you do what you want. We'll talk about it when you're done. Does anyone have a question as to what I'm asking you to do? Go ahead. All right, I'm going to let you work for a minute. I just launched a poll. If you can tell me if you're done, yes. If you're not, don't answer, but really I'm just trying to see when people are done. Okay, we're just about out of time. I wanted to make an adjustment to our homework before we finish this off. All I'd like for you to do for our homework for section 1.3 is just add problem number 3 and then do 4, 5, 7, 8, 9. We still need to talk about some other stuff here, so that should be good just for now. All right. And that will fall kind of in line with what we did today. Everyone got that? Okay, now in terms of this, I only have like 2 minutes left. So I'm going to crank this out quickly. So the way I would do this is I would go to the algebra stuff first. Like I know at -2, I have a y value of 4. So maybe I go like, here's 2, here's 4. So at -2, I put a dot up here for, I know that point exists. I also know, this is algebra 2, that at 1, I should be at -3. So if this is -2, here's -4, here's -3. So at 1, I should be at -3, I should have a dot here. Okay. That's my picture so far. Now, this part, as I approach -2, now I didn't do plus or minus, did I? I didn't do from the left or right, which means from both sides, it has to be approaching 2, which means that I approach 2 from both the left and the right. So out to the left, it has to come in, and from the right, it has to come into 2 from both sides. Your picture could look completely different. It could come out here and go up here. Doesn't matter. We just both have to have kind of an open circle with 2 tails coming out of the sides. And then on this one, as I approach 1 from the left, I need to be headed to -3. So that means as I approach 1 from the left, I need to be headed to this point. So a tail out this way. And then as I approach 1 from the right, I need to be up at +4, which is up here. Does that all kind of make sense? And then the rest is up to you. So like I'll connect these together. I don't know, I'll draw this and draw an arrow or something to make this one go down. There we go. That's a function that satisfies all those conditions. Make sure when you're done, it's a function. It passes the vertical line test. Okay, don't do any crazy, shit where you're doing this or something, because then it fails the vertical line test, no longer a function. So be careful. Okay, that's it for today. I have office hours today from 4 to 5. If you have any questions, what I would expect is that when we get together next class, we will start class with a quiz. So like And it'll be based upon what we've done here today. So I hope that if I gave you a picture, right? Like if I gave you a graph and asked you for some limits, you'd be able to figure it out. Or if I gave you some conditions that you could draw me a picture. That's pretty much the two main ideas here today. Any questions?
Just one really quick, for the quizzes, I know that there was that camera set up for, that's only for exams, right?
That's
The
only
one-
for exams. Yeah, for quizzes, it'll be kind of like what I just, what I did with that very first thing. Where was it here? Oh, no, I didn't do it. Never mind. I'll probably send out a poll and it'll be maybe be a multiple choice. It'll vary. It'll vary how I do it. So
All right.
just be prepared. That's the most important thing for you. Feel like I'm forgetting something.
You mentioned the homework about today, how you modified it.
Yes.
It's supposed to be due on the 24th, if I'm not mistaken. Are we still only supposed to do those, or?
For now, I'm saying based upon what we covered today, I think I can only safely send you to do these problems. If you go and try and do these, we haven't really talked about it. Now, will it be due later? Yes. So I will add problems onto this after next class. It's just for right now, to be safe, what's in blue and then the added one in red, those are the only things you should consider.
But to turn it in, that's on Monday or whatever. That'll
When
be
we
whatever
turn
you
this
add.
in, it'll be more complete. And you know what? I may trim these assignments down. Like I may tell you like, hey, you know what? Don't even worry about these. But let's wait till next class to figure that out.
Sure.
So it's always kind of a moving target. We're going to try for this. Let's see how it goes.
Got it.
I have a question about the ebook.
Yes.
It says that I need an email or something. Do I put like the school email?
If you don't already have an account with them, then just put in an email address to register with them, and then it should let you in. You just have to create kind of an account.
Okay, thank you.
You're free to go, but I'll hang out if you have any questions. I don't have any commitments for a little while.
Thank you.
Okay.
Have a good day.
Thank you. Have a good day, sir.
All right,
too,
thank
sir.
you.
Sir, we get our homework from like the ebook, right?
Yes.
But since we can't really get onto the ebook right now, well, at least I can't.
You can't get in at all?
No. It's
What have
saying
you
I
done?
have to pay or
It's not giving you temporary access?
no, it's not.
Hold on, let me look at something. So here's what I would do. Are you comfortable sharing your screen?
Yeah.
Okay, let me stop sharing mine. Make you a co-host. It'll help me if I see what you're seeing. So you should be able to share your screen. Kevin, you good?
Wait, what?
Who's sharing the screen? I'm sorry, was it Kevin or Devin?
I think it was the other person. I think it was Kevin.
I think I'm sharing my screen right now. Is it not showing up?
I don't know. It might be underneath a bunch of other windows I've opened.
I don't see it on my
I
screen.
don't see it. I don't see it. Oh, there we go. Okay. Okay, so do this. Close this out. Go back to Canvas. All right, go to the home page here. No. Let me see. Yeah, close that window out. The Cengage, close that one out. Okay. Now here, go to home. Go to modules. Let me see here. Whoa. Okay, no, hold on. Scroll down. Well, scroll down. Let me just see what's down there. Okay, go back up. Go ahead and click on the ebook again. Okay. Okay, so scroll down. Scroll down. Bottom right-hand corner, click on that. Yeah, click on that.
Before, it wasn't even allowing me to see all of this.
Yeah,
So-
well, they've been working on getting it fixed, so that could be it. Close that out. Close that out, and there you go. You should be able to get to the sections now.
Okay,
Yeah,
thank
good.
you for this, because before it just was like on the screen, it's like either enter an access code or pay for it, but
Yeah.
now I'm in it now, so.
Okay, cool.
So I'm
Hopefully
good.
it'll stay. Hopefully it'll stay like that.
Yeah. So I'm gonna head out.
All right,
Thank you for the
cool.
lesson.
No problem. Thanks for your attention.
I was having the same problem. Thank you, Professor.
Got it. So it's working better now for you?
Yes, I can access the book. Thank you.
Jose, same thing, or?
Okay, I apologize. I think I'm a step behind, so I have to close this Cengage and then go back to the book, right?
Yeah, do you want to share your screen or no?
Yes, sir.
Go
I'll do
ahead.
that. What's this one?
Yeah, click on ebook, see what happens here. Is your background a bunch of stars also?
Yes, but I do have like an overlaid background for something else.
Yeah, no, I was just curious. Okay, now back down to the bottom right. So scroll down and then click bottom right. There you should be able to get the ebook.
Despite this trial thing?
You just ignore that for now.
Okay.
They're gonna fix that.
Okay.
Oh, they better fix it. They keep telling me they are.
And this is how it should look.
Yeah, so close that. So now, if you want to do your homework for this, what you do is, yeah, go ahead and close that out. So click on the very first subject up there, functions and limits, click on that. And then you're going to want to do the exercises for 1.3. So scroll down, see where it says 1.3 exercises.
Yes, sir.
Click on that. And then let it load. You're going to be doing number 3.
Okay,
So see, it gives a function right there.
Okay.
And you're supposed to read it and, you know, answer the questions for these limits. And yeah, and then do number 4. Make sense?
Yes, sir. And we'll do it on paper, of course.
Yeah, just do it a paper. So you don't have to copy the graph down stuff. It's really just, you know, again, are you look, I mean, you can click and see the answer, you know,
That right.
but
Right.
for the odds, it's really not about that. It's more about you just kind of like just practicing writing the notation and everything else. So, okay.
Yes, sir.
All righty.
I believe that's it. Thank you so much.
Yep. No problem. We'll see
See you
you.
in class.